Hi, I'm Ron Covell. Today we're going to build a chopper frame. Let's start by talking about what a chopper is. Where the term comes from is that years ago people used to buy a motorcycle, they'd take it all apart, and they'd chop the frame into pieces so they could reassemble it to give it a different look. And the chopper look is all about exaggeration and paring it down. So typically it's a low, lean style. Very often the front end is extended, and it's all about this exaggeration. I love the look of a chopper. Now you certainly can buy frames to build a chopper, lots of people do. So if you can buy a frame, why might you choose to build one instead? Well, there's some good reasons. The first is you can save money by building your own frame. Another reason is a lot of people get satisfaction from riding a motorcycle they know they built from the ground up themselves. I find it's a great form for creative expression. You can express some wonderful ideas through a certain design of motorcycle. So let's take a look at some of the design elements that go into making a motorcycle frame. Alignment of the wheels is probably the place to start. Whenever you're making a frame, it's absolutely essential that the front and rear wheel be aligned in two different planes. The first is they have to be aligned in this plane, and the second is they have to be aligned in this plane. If it's off in either plane, you've got a bike that doesn't handle well. So we're going to show how to build a frame that is very accurately positioned in terms of all its components. Let's talk about some of the design elements that go into building a frame. We're going to talk about stretch, rake, and trail. There are different ways you can stretch a frame. We can stretch it in the backbone, and what that does is it pushes the fork out, making the bike longer. We can extend the down tube, and what that does is it raises the steering head, enabling you to use a longer fork. We can also stretch the rear wishbone, which pushes the rear wheel back, giving the bike a longer, leaner look. The rake is the amount of angle that the fork has to it, and part of the chopper look usually involves accentuation of the rake. Another concept is trail, and that's just a little more difficult to define. If you draw a line through the bearings of the fork, that line will touch the ground at some point, and that point is always ahead of the point where the tire touches the ground. The distance between those points is the amount of trail that you have. And 4 to 6 inches is a good range to shoot for, with 6 inches being better for a bike that's designed for highway travel without a lot of maneuvering, whereas 4 inches of trail might be better for a bike that you want to do a lot of low-speed maneuvering with. Your fork design will determine the amount of trail you have, and special offset trees are available to help adjust trail if a standard tree would give you too much or too little. For Springer front ends, the rocker can be changed to give you more or less trail. So let's talk about the frame we're going to build today. It's going to be a simple design. It's a hardtail frame. It has no rear suspension. We're building it with sensible width tires so the frame doesn't have to balloon out around the tires. It's a twin down tube design, and let's just go through the steps to build this frame. Let's take a look at a chassis jig. This is a very nice, you might say, fully featured chassis jig. This one was built by Joe McGlenn of Crime Scene Choppers, and it has just about all the features you'd like to have in a jig. The function of a jig is to hold the key components of your motorcycle frame in position as you string the tubing from one end to the other. This tower can be moved forward and backward on the chassis jig. The height of this can be easily adjusted and locked into place, and the angle of the steering head can be easily adjusted as well. Very nice to have that adjustability, and once it's clamped down, it's really held quite securely. There's a similar set of adjusters for the rear axle. Again, this tower can be moved back and forth on the chassis jig. Once you have it in the proper location, there are bolts on the bottom that clamp it into place. The rear axle height can be adjusted and clamped into place by locking these screws. And then this fixture has two parallel 3/4 inch shafts, and these are designed to be a nice tight fit on the slot for your rear axle plate. And then there are clamping collars that go on these shafts that clamp these plates the proper distance off the chassis center line. Again, it's wonderful to have this adjustability. And another wonderful feature this chassis jig has is a cradle. And the function of this cradle is to locate the bottom chassis rails in the proper position. So there are pieces of angle iron that stick up from this cradle, and they're spaced so that if you clamp tubes tightly against the sides of the cradle, they're held at just the right distance apart. And then when you put this assembly on the chassis jig, it automatically centers your chassis tubes. So each tube is the same distance off the chassis center line. And again, this cradle is adjustable so you can put it in just the right position. So once you've established the steering head location, the rear axle location, the next thing to look at is the center line of the engine crankshaft. And then all of the other dimensions are measured from that. So we'll find the transmission mounting locations based on the crankshaft center line and everything else. There are a couple other features this chassis jig has I'd like to show you. One is that it's on casters. The casters make it easy to move to the portion of the shop you'll be working in. And also, this particular caster has a built-in leveler. And you can crank this down to bring the wheels up off the ground so it stabilizes the chassis jig. It also enables you to level the jig. And once we start working, we do want the frame jig to be level because then we can use plumb bobs and bubble levels to check the location and alignment of our parts. And another very nice feature this chassis jig has is that there is a storage tray on it. And you'll be using this constantly to put the pieces you're working on and tools. It keeps them up off the floor, yet they're at fingertip reach. So that's a very, very nice feature. So this is a very elaborate chassis jig. It would take more time and cost more to build this jig than it takes to build a motorcycle chassis. So this is more elaborate than what you'd build for one-time use. For one-time use, you might base your chassis jig on a piece of 2" by 6" steel channel and then just weld uprights onto it and make sure that everything is square and level, and you could do just as good a job with a simple fixture like that. The nice thing about this one is the adjustability. The basic construction is made of 2" by 3" tubing. There are 2 rails of that on the top surface, and they are accurately spaced with a 2" space between them, so we can make additional pieces that register in that slot between the 2 main rails, and that's what gives us the adjustability. So now that we've had a good look at a chassis fixture, let's actually put this to work and we'll start building our chopper frame. We're going to base our frame design on drawings made by Gary Weissout. Gary has an excellent website that's called the Chopper Builder's Handbook, and I'll give information, a link to that at the end of the video. But I've chosen these plans for a number of reasons. The first is that there are literally hundreds of bikes that have been built from these plans, and it makes a very nice looking motorcycle. It's a fairly easy to follow design. It's a rigid frame. The frame is made from 1¼ OD 120 wall tubing. We're going to be using an Evolution engine, 6-speed transmission. The frame is designed with the 35-degree rake. It has a 1 1/2" backbone stretch, 4 inches of down tube stretch, 2 inches of rear wishbone stretch, and the rear axle has been raised 1 inch. Now these dimensions are based on a stock Harley hardtail frame. The rear tire is a 150 series 16" and we're using a 21" front wheel. It's an excellent first-time project for a motorcycle frame builder. So that's the design we're going to base our frame on. So now we're ready to start cutting and bending tubing. The material that we're using is 1¼ OD 120 wall tubing. That's 1/8" wall tubing. And this particular tubing is DOM tubing. DOM means drawn over mandrel. DOM tubing is just a little bit higher grade than regular electroweld tubing, although you could use electroweld. That has enough strength to make a motorcycle chassis from. The reason I prefer DOM is that it's held to a little bit higher tolerances, it's a little bit stronger material, and I think I can get a little bit nicer looking weld bead on the DOM than I can on electroweld tubing. But many people use electroweld. It works just fine. So when you cut tubing, there's a variety of different tools you can use. You probably don't want to use a hacksaw because with all the cuts we need to make, that's too tedious. So probably an abrasive chop saw would be a real good choice for this. It'll make an accurate cut that's square. It needs a bit of cleanup after the ends are cut, but that's not hard to do. I use a cold saw because it's quite a bit faster and it actually leaves a smoother cut, but that's a fairly expensive tool. You could use a sawzall. A sawzall would cut through this material fairly quickly, although you would tend to get a ragged edge that would need some tune-up afterwards. So there's a variety of ways to cut the material. I've cut a piece that's just a couple inches longer than what the finished piece will need to be after it's bent. The part we're making is one side of the rear wishbone for the top layer of the frame, and it needs a 25-degree bend that starts 10 inches from the end. So the first step is to make a layout mark 10 inches from the end of the tube, and I'll show you how this is set up in the machine. The machine that I'm using is a hydraulic bender made by Mittler Brothers. It's a rotary draw type bender, and I'd recommend that you use only a rotary draw type bender for a motorcycle chassis. This one is hydraulic, but there are some good manual machines on the market as well that will give you just as nice a bend. But there are some machines you should stay away from. There are machines designed for bending pipe and electrical conduit that give you a broader radius bend, and because they're not rotary draw machines, they tend to deform the tubing so it ovalizes in the middle of the bend, making it less strong. So I'd really hold out for a rotary draw bender. So when you're working with longer pieces of tubing, it's helpful to put blocks on your table so that when you put the tubing into the machine, gravity is not always trying to make it fall out of level. And we're going to align the mark I've made with the clamping yoke on this part of the machine. So we're going to line the mark up with the edge of the yoke. Put the pin in place. Okay, so we're all set up to make the bend now. And I'm going to use a protractor to measure the angle of bend. Now, the tubing always springs back a little bit, and what I found that each lot of tubing behaves a little bit differently. So I like to do a test piece with each new batch of tubing. What I've learned from this batch is that it springs back about 1 1/2 degrees. So our goal is to make a 25-degree bend. I'm going to set the protractor for 26 1/2 degrees. Then we'll make the bend to 26 1/2 degrees, and we'll measure it again when it springs back. Okay, so I'm going to step on the foot pedal. Move the protractor where I can eyeball it a little bit closer. Almost there. I'm just eyeballing the edge of the protractor against the edge of the tube. Looks like it needs about 1/2 degree. Okay, so the bend is made to 26 1/2 degrees. Let's back the bender off. And we'll take the tubing out of the machine. We'll take the yoke off. One nice feature of this machine is the top bar hinges back, making it easy to release your tubing, and it helps to tap this die off with the mallet. So there's our bend. I think you can see it's a very nicely formed bend. Very uniform, very smooth. There's almost no ovalizing at all of the tubing. It's come out very nicely. So let's reset our protractor to 25 degrees, and then we'll test the bend to see how close we got. And ladies and gentlemen, we're right on the money. Okay, so our first piece is bent. We need to bend another piece just like this, and then what we'll do next is we're going to assemble the whole top rail of the motorcycle frame. So that's the wishbone and the backbone. We'll put those all together as a unit. We're going to use our fixture to hold the first 3 pieces of tubing together. There's an attachment that goes on this that centers the backbone in the fixture. So we'll put that into place. We'll put the backbone against this part of the fixture. We'll just hold it with spring clamps. And then the rear wishbone section goes in the cradle. This cradle is designed so that the elements that are vertical are 10 and 7/8 inches apart, which is the actual finished dimension of the chassis. So we'll hold this to the fixture, to the cradle with clamps. And now we can look at how these pieces of tubing fit together. Now where we're going with this is that the wishbone needs to be notched in such a way that it's a very snug fit against the backbone. And I'll show you a couple of different ways to do that. But before we start the notching, I want to cut away some of the excess material here. So I'm going to hold a straight edge right down the center of the backbone and then mark a line for trimming on the wishbone. Now we'll use a saw to cut away this excess material, and then we'll be ready to start the fish mouthing that will allow these pieces to fit together. Okay, now our cut is finished. Now we'll do the fish mouthing on this piece of tube. So I'm going to be using a milling machine to put the coped cut on the end of this piece of tubing. So I have the vise set up so that I can clamp the sides of the tubing in the vise. Then I'll use these hold down clamps to hold the tubing tightly against the table. We really need to hold this tubing rigidly as it's being machined. Okay. Then we'll retighten the vise. Now the cutter I have in the machine is an 1¼ OD with a ball end. It's called a ball end mill. That means the nose of this end mill is a complete half circle. And if we make traversing cuts across the end of the tube, it's going to cope out a section that will fit perfectly against the backbone tube. So let's get started. So the procedure is we're going to make a light cut to the right, raise the table a little bit, make a light cut to the left, raise the table a little bit, and keep traversing and raising the table until we start getting the cut dialed in. So we've just made contact with the tube with the cutter. Now I'll raise the table 50 thousandths, move the table toward my right. I'm using a little cutting oil on the cutter. Okay, raise the table 50 thousandths more, go the other direction. Raise it 50 thousandths more. Go back the other direction. Okay, so we'll take this out now, clean it up. I think you can see it's made a very nice fish mouth. So the milling machine does a beautiful job of cutting the shape we need, but it leaves kind of a ragged edge. So we're going to use a belt sander to take the burr off the edge of the cut tube. Okay, so we have the tube deburred now. Now we can do our test fitting against the backbone. And I intentionally stopped this cut a little bit short, so I expect we'll have to trim it 1 or 2 more times to get the kind of fit we want. So we're going to put these pieces of tubing back in the fixture again. I'll clamp the wishbone to the cradle, and now we can look at the intersection. Now the fit is good, but the fit has pushed this tube off center about 1/100,000th of an inch. So I'll put this back in the milling machine, and rather than shave off 100,000ths all in one step, what I'll probably do is take off about 50,000ths, come back, retry the fit, gauge again how much has to be taken off, and we'll kind of sneak up on the fit that we want. Of course, the problem here is that once you've cut off too much, you've got a gap, so I want to take a bit of time to get the fit just as nice as we can get it. So we have a perfect fit on this tube now, and we're getting ready to weld the pieces together. The fish mouthing has given the tube a razor edge on this section. And the problem is, if we put a weld on top of this razor edge, the weld can be strong, but the section of the tube the weld attaches to is weak because it's thin. So what we need to do is to sand this edge back so when the weld goes into place, the weld is attaching on to the full wall thickness of the tubing. So I'm going to use the belt sander to knock these edges down. If you don't have a belt sander, you can use a disc sander or a handheld sander, whatever it takes to get this down to the full wall thickness. Okay, so we've sanded that razor edge back, and now we have a full thickness wall of the tube in the place where the weld's going to go. So we're going to fish mount the second wishbone with simpler tools. The first step is I want to do rough trimming on this tube so there's not so much material to remove. So I'm going to clamp this back on the fixture to see how the wishbone aligns with the backbone, and I'm going to make some marks on it. I'm going to make a mark that's tangent with the front edge of this tube. I want to make a mark that's in line with the center of the tube. And I want to make a mark on the back side of this tube that's in line with the front surface. So I'm just going to eyeball down to that. Okay, so we have 3 points identified on the tube. And now I'm just going to sketch in a line that connects the 3 points, and this is only approximate, but I think this is the line we'll do the rough trimming on so that when we do the final fit we won't have quite so much material to remove. So we'll go to the bandsaw now and chop off most of this waste. Okay, so I made 2 cuts to approximate the shape that we marked out. Now we'll take this over and put it in a vise, and we'll start carving this shape out with the little drum sander. Okay, let's try it again. Hey, looks like we've got a real good fit. So after about a half an hour and about 10 trial fittings and about 6 sandpaper drums, we finally have gotten a very, very nice fit on this piece of tubing. The piece we hand fit rivals the piece we cut with the milling machine. Of course, it's taken much longer, but if you don't have a mill, this is an excellent way to get a super fitting joint. So the very next step is I'm going to use a Scotch-Brite strip and clean wheel to take the mill scale off these parts in the areas where they're going to be welded. Now we'll clean the wishbone ends and we'll be ready to stick these pieces together. I'm going to use some acetone to clean any grease off of the surface. I put a mark on the backbone with the dimension from the drawing that shows me exactly where these parts fit together. We'll clamp them into place. I'm going to use acetone to clean the welding rod. You never know if your welding rod may have become contaminated. And now we're ready to do the tack weld. All right. So here's the first segment of our motorcycle frame tack welded together. Okay, moving ahead, I've made a temporary brace that fits between the legs of the wishbone. This will just be used to hold the legs in alignment as we do the fitting on the rear axle plates. Moving toward the front, a lot of times it's important to know which components you'll use as you're building your frame. In this case, I'm going to be using the crime scene chopper seat, which mounts on springs. And I need to have the cross member between the wishbone legs positioned so they intersect the springs for the seat. So I'm moving this brace up a little bit in comparison with how it's shown on the plans. But I have the position of this brace plotted now, and the next step is we're going to actually fit a piece of tubing to become that brace. This is the tubing we'll be using, and I need to make notches on each side at 25 degrees. So we're going to be using a different type of notching device for this. This is called a drill press notcher, and these come in all different styles at all different price points. This actually is a fairly inexpensive one. This one is about $80, and you can get them all the way up to about $250. The ones that cost more work a little better, but even this inexpensive one should work fairly well. So it's possible to adjust the angle of the miter. There's a movable part here. I'm going to move this down to 25 degrees and lock it into place. Okay, and now we're ready to do our notching. So I'll put my face shield on, turn the machine on, use a little cutting oil, and we'll start notching. Okay, our cut is finished. Let's take this out now, and we'll try it into place. So that fits very nicely on the wishbone. What we need to do now is mark the other side, trim off the excess, and we'll use the same notcher to make the coping cut on the other side. Then we'll clean these off, tack weld them together, and we'll be ready for the next step. Now it's time to get the chassis jigs set up. The first thing we want to do is to use the levelers on the feet to get it set level, both front to back and also from side to side. So that's all set. Now we're going to focus our attention on the steering head, and the first step is to set the angle. Now the angle we want on this is 55 degrees. One good way to set the angle of the steering head is with the bubble protractor. You can get it within about half a degree using a bubble protractor, but an even better tool to use for this is a digital protractor. This can give you 1/10 of 1 degree accuracy, and it's a little more convenient to use, and the price on these has come way down, so you might want to look at getting a digital protractor. They're really quite a nice tool. So now that we have the angle of the steering head set, the next thing is to set the height, and that's where it gets just a little bit tricky. Now the way the drawing is dimensioned is between the center line of the steering head and the center line of the backbone. That line of intersection is 32 inches up from the bottom of the chassis. Now all of our dimensions have to have 1 inch added onto them because the cradle we're going to use to hold the lower tubes is 1 inch thick. So adding 1 inch to 32 inches gives us 33 inches. And this line of intersection needs to be 33 inches up from the base of our chassis jig. So I've clamped a scale, a ruler, onto a 90-degree square, and I've adjusted the height of the steering head so the lines of intersection are up 33 inches from the top of the chassis jig. So I'm going to use a Sharpie marker to mark a point on the jig that's directly down from these lines of intersection. And now that that's done, I'll use a combination square and I'll transfer that line all the way across the chassis jig. So this line is directly down from the lines of intersection of the center line of the backbone and the center line of the steering head. This is the point from which we locate the center of the rear axle. So I'm going to use a tape measure to measure back 50 1/4 inches from our layout line. Now the front edge of this tower is in line with the center of the slot in the rear axle plate, and I have this positioned at exactly 50 1/4 inches. So the front to back position of this tower is already set perfectly, and the rear axle plates fit on this holder so that they are centered, and there are stops that locate the angle of the rear axle plates, and there's a clamping collar that will hold this firmly in place. So the last thing we have to set is the height of the rear axle. And the height of the rear axle measured from the bottom of the frame is 8 5/8 inches. Adding 1 inch, we need to have the center of the axle 9 5/8 inches up from our chassis jig. So I've already established that height as well. So now we have a target to shoot for placing the top layer of tubing in the chassis jig. So I've already welded together the elements that make the top layer. So the wishbone and the backbone are joined, and while I was at it I put on the pivot for the seat. So what we need to do is to get the miter cut at the front of this tube, and then we need to cut the slots that go over the rear axle plates. From the drawing, I know that the dimension from this point to the start of the miter is 30 inches, and I know that the angle of the miter is 11 degrees. So with that information, I can go ahead and cut the miter. Once the miter is cut, I'll hold this into place temporarily, and I'll mark the intersection of the rear axle plates against the wishbone. Then I'll know where to put the notches. So we have the tubing clamped in the milling machine vise now, and it's properly positioned. We've centered the vise on the hole saw we'll do the cutting with. I've put a mark on the tube 30 inches from the end, and this is the base of the coped cut. So I have that mark aligned with the edge of the hole saw. We put the part in the vise at 11 degrees. It's also very important that you get the part in the vise level, because that's a place you could make an error. We don't want that notch cut to come in at an angle. So we're all set to make the cut. Let's turn the machine on and we'll start notching. Okay, we finished the cut on the part. Now we'll take this out of the vise, we'll deburr the part and try it back on the chassis jig. Now with this stage in the process, you're going to wish you had 3 hands. It really is quite difficult to hold all this stuff together. So I've made a temporary brace I can use just to clamp the backbone against, and this really helps hold everything together. So now we can take a look at the fit we have against the steering head, and it's a perfect fit. We got the angle just right. So now that the front end of this member of the chassis is fitted, now we can switch our attention to the back end and start taking a look at how the wishbone needs to be fitted to the axle plates. Now I want to talk a little bit about the axle plates themselves. I made these rear axle plates the hard way. I bandsawed them out of 3/8 inch thick cold rolled steel stock, and I used a milling machine to cut the slot, and they came out very well, but it's a slow process. These parts could be easily made by the water jet cutting process or by laser cutting. Both of those processes are quite affordable now, and it's an excellent way to make parts of this nature. Also, I mentioned that I use cold rolled steel plate. You certainly could use hot rolled. Hot rolled has almost as much strength. The only disadvantage to hot rolled steel is that it has a scale on the surface, and it's difficult to get the scale off, and the scale can interfere with the welding process. Our goal here is to trim the wishbone, and I've drawn a line that shows how far back it goes on the axle plate. Then the next step is to notch the wishbone so the axle plate fits into it. So let's put the axle plate on the fixture, and now we can see how far back the tube needs to be trimmed. I'll make a mark with a Sharpie marker. So we'll trim the tube at this line, and we'll make another line showing how deeply the tube needs to be notched. One more step of refinement is that I want to cap the ends of the wishbone before we do the notching. So if you have a lathe, you can certainly turn caps from solid bar, but that's a pretty tedious process. It turns out that you can buy ready-made caps for tubing, and it really is a time saver. So we'll tack weld this cap onto the second wishbone leg, and we'll be ready to go. At the end of the video, I'll give you the source for buying parts like this. We have 2 notches to make. I'm going to use the milling machine to do the first notch, and then I'll make the second notch using simpler tools. So we have the part clamped in the vise. I was very careful to get the part level in this plane when clamping, because I think you can see if the part's allowed to be crooked, your slot's going to be crooked and it won't match the axle plate. So we're using a 4-flute cutter for this. I'm going to traverse back and forth as I cut and slowly move the table up, and we'll cut cleanly through the tubing. Okay, so we've cut about halfway through the tube at this point. What we'll do next is to flip the tube upside down, cut through the other side. So you can see what a beautiful job the milling machine does of notching tubing, but I'll show you how you can notch it just as well with simpler tools. With the drill press, I drilled a hole all the way through this tube, and I was very careful to center it. Now I've made a stack of just scrap metal that comes up to be tangent with the bottom edge of the hole, and we'll scribe a mark on this. Now we'll put another block on top of this so our stack of material is tangent with the top edge, and we'll scribe another line there. Okay. Now that the layout lines are in place, we're ready to make the cut. And I'll be using a cutoff wheel in an electric die grinder. Okay, so we'll flip the part over, cut through on the other side, clean it up, and then we'll take a look at these two sides. So we've done just a tiny bit of tune-up on the hand-cut side, and now you can see that the fit we have is almost perfect. It's just about as good as the one we cut on the milling machine. So two different ways to accomplish the same task. Okay, so what's next is we're going to put the axle plates permanently into place on the fixture, and then we'll do the test fitting of the top layer of the chassis. So we have the axle plates positioned on the fixture now. So we'll do the first test fitting of the upper level of the chassis. Make sure those notches engage the plates. And by gosh, it looks great. Still have a very nice fit up at the steering head. Perfect fit at the rear axle plates. So what's next is we'll tack weld this into position, and then we can start fitting the bottom rails of the chassis. So I've made a full-size layout of the motorcycle chassis, and this is going to help me when I go to position the bends and the tubing. We're ready to make the bend on the down tube of the chassis now. From the drawing, I know that this bend needs to start 24 inches from the top of the tube. So I'll measure down 24 inches, put a mark on the tube, and then we'll align this mark with the clamp, the clamping yoke of our bending machine. Put the follow block on the back side of the tube. Get the proper alignment of our bending mark. So the bend needs to be 40 1/2 degrees. And I know that it's going to spring back 1 1/2 degrees. So we're going to set the protractor to 43 degrees. So one leg of the protractor I'll put tight against the follow block, and I'll watch the tube as it bends and stop when it's parallel with the other leg of the protractor. Okay, getting close. I think we're right on the money. So let's pull this out. We'll reset the protractor and check it. So we're shooting for 40 1/2 degrees. Let's set our protractor to 40 1/2. We'll put it on the tube and see what we got. Pretty darn good. Okay, so the first bend is in place. Now the layout for the second bend is a little more tricky, and I'll show you how we do that. So the tricky part is to get bend number 2 and bend number 3 in the lower rail to be accurately positioned in relation to bend number 1. And I'll use a full-size layout drawing in conjunction with the test bend to help find how to do that. So the test bend has a clear mark on it that's in line with the clamping yoke on the tube bending machine. We'll slide this tube back and forth until we have perfect registration with the bottom rail of the chassis. And when they're in alignment, then I'll make a mark on a layout drawing that shows where that bend layout line needs to be positioned. Okay? And as long as we're down here, let's go ahead and do the same thing for bend number 3. So again, we'll slide this test bend back and forth until we have perfect registration with the kicked up section on the rear of the chassis. And when they're in alignment, then we'll transfer this bend line onto the drawing, and that's the line we'll use to position the bend layout line on the tube. Okay, so let's go ahead and put our first piece, our first bend, onto the drawing. We'll position this very accurately. I'm going to slide this down until we have perfect registration on the down tube portion of the bend. Okay, and then we'll make our bend layout line on this tube. So now we can put this in the bender and we can make bend number 2 with a good degree of precision. Again, we'll put the clamping yoke right up against the layout mark. And then I'm just going to put a little pressure on these dies. Now this next part is crucial. We want to make sure that bend number 1 and number 2 are in the same plane, and to do that we have to make sure that this leg of bend number 1 is level before we put bend number 2 in it. So I'm going to use a bubble level and get the angle of the tube this way positioned properly, and then once it's positioned we can go ahead and make our 40 1/2 degree bend. Okay, so we're coming right up to 43 degrees. All right, the bend's complete. Let's take it out of the bender. And we'll check the bend we've made. Excellent. So now we need to make this bend on the second piece, and we'll be ready to start fitting these pieces to the rest of the chassis. So let's put this in the cradle, rotate it over until it touches the backbone. Now the way this is positioned is that the front edge of the down tube is 5/16 of an inch back from the steering head. So I'll get a piece of stock 5/16 of an inch thick, slide this forward until it just touches. So we've established our spacing now from front to back for the down tube. And the next step is that I'll get a small square and make a mark on the down tube in line with the bottom of the backbone. So our coping cut will intersect that line. And the last thing we need to know is the angle between these tubes. So I'll put a protractor into place and adjust it so it's a nice tight fit against both tubes. And it's measuring 34 degrees. So we need to make a coping cut on the down tube that intersects this line at a 34 degree angle. So I have the tubing clamped in the vise on the milling machine now, and I've angled the head of the mill to 34 degrees. So now we're set up to make this cut. I'll turn the machine on, and as the cutter is rotating, I'll be feeding the tubing slowly into the cutter. Okay, I've stopped this cut about a 1/4 inch short of our mark. I want to do a test fitting back on the chassis, and we're going to sneak up on the fit of this. I don't want to cut this too deeply because I'd have to make a new tube if I did. Okay, this is our third test fitting. We should be getting close now. We'll put the down tube back in the cradle, and by gosh, we have a perfect fit at the joint between the down tube and the backbone. There's one more cut we need to make on this tube. We need to slice off the inner face where it meets the other down tube. And I'm going to use a carpenter's square to help lay out that trimming mark. So I'll slide this over until it just touches the center line of the backbone, and then I'll use a felt tip marker and make a mark straight down. And now this is our trim mark for the down tube. So I've marked the cut all the way around the tube with the felt tip marker. We'll make the cut with a cut-off wheel. Okay, we finished our cut. Now we can clean these up and see how they fit together. Okay, let's fit these two sides together and see how they match. Excellent fit. Okay, what's coming next is we need to lay out the last bend in both bottom tubes, and to do that we need to measure this angle. You'll see why that's important very shortly. So this angle measures 83 degrees. You'll see how we use that number to make the last bend in the bottom tubes. We're set up now to make the last bend in the bottom rail. We already laid out the location of the bend, but what we have to do now is to lay out the angle of the bend, and I'm talking about the angle of rotation this way. The first two bends are in the same plane. This next bend is not. When we measured the angle of the down tube, it was at 83 degrees. Now that's 83 degrees off of a horizontal line. Because we've laid the tube down on the table now, we need to set this leg of it at 7 degrees so the third bend comes out in the proper orientation to the first two bends. I'm going to use our digital level on this leg and set this tube to exactly 7 degrees. Okay, now we're ready to make the bend. The bend we're making is 28 degrees, and with the spring back we'll get, I need to set our protractor to 29.5 degrees, and we'll put the protractor into place and make this bend. So our bend is completed. Let's release it from the bender. Okay, so we made both bends now. Let's try both bends into place. And what I'm looking at is that when it's tight in the cradle, we have a nice fit against the bottom of the axle plates. Looks like we're in real good shape there. So what's next is I'm going to go ahead and weld the caps on the ends of these tubes and do the notching to fit over the axle plates. So we have both of the bottom rails fitted into place now. The notches fit the axle plates perfectly. So what's next is there are a couple of cross members that go in this frame, and I'm going to make those from 1 inch by 2 inch rectangular tubing. So what we have to do is to make notches in the end of this tubing where they fit against the side rails. The first cut we'll make in the drill press using a hole saw. Now the center of the hole is about 1 inch from the edge of the tube, and that's important. If you try and make a cut close to the edge with a hole saw in the drill press, there is a side loading you get on the cutter because the teeth on only one side of the cutter are engaged with the metal, and that's going to pull the hole saw off center. So all of the teeth need to be touching the metal. So I've made a pilot hole about 1 inch from the end. The hole saw has a center drill, and it will follow that pilot hole. So let's go ahead and cut halfway through from this side, then we'll flip the part over and finish the cut from the other side. Okay, we'll flip the part over and finish the cut from the other side. Make sure it's centered under the cutter. Clamp it in the drill press vise, and we'll continue. Okay, so I've deburred the tube. Let's try it into place now. And you can see we have an excellent fit against the frame rail. Okay, so one side is done. We need to lay out the cut for the other side now. The distance between the frame rails on the inside is 8 1/4 inches. So I'll use a scale to lay out 8 1/4 inches. We'll make a mark. And now the second coping cut needs to intersect this mark. So we're going to use the milling machine to make the second cut, and the milling machine is designed to take a side loading on the cutter. So we'll be able to start the cutter rotating and then just feed the tube into it as deeply as we need. And the nice thing about cutting this way is we can sneak up on it. We can cut close to the mark, take it out, check the fit in the chassis, come back and shave off just a little bit more. You don't get to do that with the drill press. Okay, we'll take this out and try it in the chassis. And now we have the cross members fitted in place, but there's one more step to take before they're tack welded. It's important to drill a little pilot hole in a tube before you weld it. If you don't have that venting hole, pressure builds up inside the tube, and a lot of times just as you're finishing the last weld, it can blow through. And I've also drilled a pilot hole in the center of the front cross member. This is in preparation for fitting the seat tube, so the gas that would be trapped in the seat tube has an escape path. And we also need to fit the gussets for the steering head. So there's a vertical element that fits here and a horizontal element beneath it. And they both need to be tack welded into place. These are both made out of 1/2 inch plate, which is plenty stout for this application. Okay, so now we have the neck gussets welded into place. The next thing we're going to do is to fit in the brace for the head of the motorcycle, and I've pre-cut the parts. There's a short tube that fits between the two down tubes, and then there's a longer tube that attaches to that, and the end of this is notched to fit against the backbone. We'll put the small tube into place between the down tubes, and then we'll hinge the longer tube up into place, and you can see it's a very nice fit up against the backbone. So let's go ahead and tack weld these into place. So we have this tube tack welded into place. I might mention that I'm using a new welder. It's an inverter style welder, and I've come to like this quite a bit. One advantage is that it can run on any voltage between 115 and 440. So the nice thing about that is I can take it home and plug it in my kitchen and weld it home. It's a very lightweight machine, very portable, but it really has a nice stable arc. So the very next thing we're going to do is to fit the seat tube into place. So I pre-made the seat tube. It's a fairly simple part. It has a notched end where it meets the backbone, and the bottom end is just a square cut, so it's an easy part to make. Because we're using a 6-speed transmission, which is configured a little differently from the 4-speed transmission, I found I had to put a 12-degree bend in the tube to clear the transmission. But with that exception, it's just like the drawings, and it fits against the backbone 1 inch up from the back edge, and it's centered in the front cross member. So let's go ahead and tack weld this into place. Okay, so now we have the seat post tack welded into position. Now comes the part we've all been waiting for. We're going to put the engine and transmission into place and fit the mounts for them. So this is the rear motor mount. It's just made out of 1/2 inch thick cold rolled steel plate, and I'll show you where it fits onto the engine. It goes right in this little cavity in here. Let's go ahead and tighten the rear motor mount, and what we're doing here is we're checking its fit against the seat tube. We want to make sure we have an excellent fit there before we tack weld them together. The fit is excellent, so we're looking very good with the location of the rear motor mount. Now the very next thing I want to do is to carefully measure this engine and transmission. I want to make sure that it's parallel with the center line of the frame, and I want to make sure that they're absolutely vertical, so it's not tipped to one side or the other. So once I've checked that, then we'll be ready to fit the transmission mount and the front motor mount. This is the transmission mounting plate, and I've made this a little different from the standard style. Usually they're removable. They're held into place with bolts and they can be unbolted. I chose to make this so it's welded into place because I think it makes the mounting a little bit cleaner. And I've made it from thicker plate. It's made from 1/2 inch plate, so it could be relieved to clear the bump on the bottom of the transmission. Also, it's counterbored on the bottom side so that the nuts can have full engagement with the studs that stick out the bottom of the transmission. And of course, it's notched to fit around the seat tube. So I've double checked the fit of the engine and transmission, and I'm very happy with the alignment. So let's snug up the transmission mounting plate and check its fit against the seat tube. And it looks like we have an excellent fit. So we're in good shape with the location of the transmission mount. Now let's check out the front motor mount, and if that looks good, then we can start tack welding these into position. Here you can see the blocking I've used to establish the correct height for the engine. And you can see what will become the top motor mount. It's a piece of 1 inch square solid steel bar, and there are holes drilled through it that match the mounting ears on the front of the engine case. So we need to make a bracket that connects the front motor mount to the frame tube, and very often the forward controls attach onto that same bracket. Now we're going to be using a different style of forward controls on this motorcycle, so I am going to make a very small bracket, the smallest that is necessary to tie the square bar into the frame tube. So that's all it's going to require on this motorcycle. So it looks like we're in good shape now. The next step is to tack weld the front motor mount, the rear motor mount, and the transmission mount into place. Then we'll be ready to do all the finished welding on the chassis. After that, we can assemble the other components of the bike, and we'll be on the way to completing this project. Okay. So I've done as much welding as I can with the frame still on the jig. I like to do as much welding as possible with the frame and the jig and with the engine and transmission mounted, because my thinking is that having those components clamped down might help eliminate a little bit of the distortion that can happen with welding. So I mentioned before that I prefer the TIG welding process without really telling you why. I like the control that the TIG process offers. You have wonderful control of the heat, and the TIG process can give you some of the nicest looking beads available. Now many of you will be using MIG welders, and there's absolutely nothing wrong with MIG welding. It can give you a very strong weld, but with any welding process you should be very sure that you're competent with your welding process. You want to be sure that the welds have as much strength as the metal you're welding together. Obviously, people's lives could be at stake if a weld on a motorcycle frame breaks. So if you're not quite sure that your skills are up to par, it might be good to have someone else do the welding on your motorcycle frame. So moving ahead with the project, we're going to take the frame off the jig, take the engine and transmission out, I'll complete the welding, and then we'll start tying up some of the loose ends on the motorcycle frame. We're going to change direction just a little bit and focus on the fork of the motorcycle. Now I'm sure many of you will choose to buy a fork, and that can be a great way to go, but I'm going to show you just a few steps that you would take if you're going to make a fork. So the fork I'm working on is based on plans made by Crime Scene Choppers. I have the parts all pre-cut and ready to assemble. So what's in front of me is an attachment for Joe's chassis jig, and it's an attachment designed for locating the fork pieces in preparation for welding. So there are stations that go onto the chassis jig, and I've positioned these stations in such a way that I can clamp the plates tightly to them, and what that's going to do is to give me the alignment of the tree, the lower tree, and the alignment of the spring plate. That alignment would be difficult to achieve without a fixture of some sort. So let's go ahead and get these parts clamped into place. So I'm clamping the lower tree to the middle station. So now we're ready to tack weld and then finish weld these parts together, and then we'll work on the next element of the fork. Now we're going to focus on the front fork legs. So I've pre-bent them and cut them to size, and we'll put them in the fixture here, which maintains the proper spacing between them. And our goal now is to fit this dog bone that ties together the tops of the two front fork legs. So let's get all this positioned in the fixture. I'm going to bring this fork leg up so it's absolutely flush with the top of the dog bone, and then clamp the dog bone to the station to ensure its alignment. And by gosh, we're ready to weld these parts together. The triple trees are assembled on the head now with the bearings in place, and now we're ready to look at some of the other components of the fork. We've just tack welded together the front legs of the fork, and we're going to position those into place pretty soon. What I like to do at this stage is to cut these legs a little bit long, because it's difficult to predict exactly how much the springs will compress when the weight goes on them. So if you cut them about 1.5 inches long, then they can be shaved down to be just the right height once you reach that point. And let's look at some of the other components that will comprise the fork. Joe makes these special ends for the fork tubes, which you can purchase pre-made, because this would be a very tedious part to machine one at a time. And these are the rockers for the fork that the front wheel will attach to. And again, Joe provides these as water jet cut parts, so they just need the final machine work and cleanup, and they're good to go. So we'll go ahead and assemble the rest of the fork and do our test fitting with it. So we have the fork completely assembled, and now it's time to wrap up the last few little details. We're going to get the forward controls mounted. This is the master cylinder and its mount. We'll get this welded into place. And I'm going to get a battery mount welded into place. And you might notice that these parts have fancy holes in them. They were cut using the water jet process. Great way to get fancy parts with interesting holes. So we'll get these welded into place, and we'll assemble the components of the motorcycle. This is the part of the job that's most gratifying for me. Now all of the metal fabrication is done on the frame and the fork. We start assembling the components, and it becomes a motorcycle for the first time. A couple of things I should have mentioned earlier. When you're buying tubing for your motorcycle frame, buy a fair amount of extra tubing, because you really can't expect perfection with each cut and each bend. Another thing is, when you're making the final welds on the motorcycle frame, don't weld any one joint all at one time. Make a small weld in one area, skip to another area, and keep skipping around until your welding is completed. That will minimize the distortion. So I think you'll get a great deal of satisfaction when you finish your motorcycle project, and I encourage you to get started. This is Ron Covell signing off.